And welcome back. Today we're going to cover the OR possibility in logical operators. Last time we did AND, this time we'll do OR. OR works, interestingly enough, kind of like AND. When AND makes a decision, AND checks a true value against another true value and decides it's true. If anybody in the pipeline there are false, then it's instantaneously false. So you can consider ANDs to be narrowing down your scope of events. ORs allow you to expand your scope of events. If these are the conditions, here's condition 1, here's condition 2. If the condition is true, first one is true, or second one, then automatically this is going to be true. If A or B is true, then it's true. So if A is true and B is false, it's true. The whole test is true. If A is false, we kind of have to know what the other one's doing. We have to look and see, yep, there's B. B is true, so therefore the whole condition is true. If A is false or B is false, if they're both false, then the condition's false. And the surprising thing is this is incredibly like the AND. It's the exact opposite of it. So here we just dropped into our screen the AND table for checking two things. So here we go, AND. Once again to remind you, if condition A is true and B is true, then it's true. If condition A is true and B is false, it's false. If condition A is false, it doesn't matter what's going on up here, it's going to be false. And if you look at this table, the OR table versus the AND table, you'll see that they are exact flips of each other. So you can almost think about things in an interesting way. If we wanted to turn things around, we could say not in front of this. So if we remember the logical operator not, the logical operator not is the exclamation point. Basically means if it's true, then if you put not in front of it, it's false. So if we take not and it's false, then not false is true. This just flips it on its head, logical not. So or, if either one of these is true, then the table shows true for the result of the test. If either one of these are false for AND, if either one is false for AND, then the table shows false for AND. If we flip not in front of it, we can flip one to the other. Kind of an interesting side note on things. But this is our logical operators and our logical tables for doing double tests. And if you remember last time when we talked about the AND symbol, just like the AND symbol, the OR symbol must have a fully functional test on both sides of the symbol. So let's play. I've got a number here and a letter here, and I'm going to ask the user for a number. And I'm going to ask him for a letter. Since it's a character, all we'll get is 1. And we'll skip the white spaces that came after number, just to remind everybody of that still existing. So what we're looking for here is we want to determine, was that letter an X? We'll pretend like this number is supposed to be hexadecimal if the letter is an X. So we want to do a test. So we want to test, generally speaking, if we have a positive number, we want this number to be positive. We're pretend like we're dealing with only unsigned hexadecimal numbers or something. And we want to let this letter be the X. So we can do a test. If the letter, or if the number is greater than 0, and the letter is a lowercase x, there you go. Otherwise, here we go. So now we see AND. Now, what would OR do to this thing? If we replaced AND with OR, that would mean if either one of these are true, If this is true, we have a positive number, or we have an x, we end up with a hexadecimal number. So that's kind of an interesting equation. If you use or versus and versus or, you'll get wrong answers. You have to be careful with how you word things. So this is just a quick way of showing that the or portion of it here wouldn't work quite right. But we can play with this a little bit. We can say, okay, pretend like we don't really care whether the number is that, but if it's an x, we definitely want it. And if it's any number over here, we're going to turn it into a hexadecimal. Then you'd have this thing right. Oftentimes, ORs are used to be what we call expansion in selection. Anytime you use OR, you're allowing yourself to get more opportunities to succeed. So if you want to just think of it in terms of language, if I have money and I have gas in the car, I party. So if I have money and I have gas, I party. So this is the test. Now you can see that if you don't have any money, but your car has gas, you don't get to party with the basis of the and. So we'll even play with this a little bit. So if I have money and I have gas, I party. Do I have money? No, I don't party. Do I have money? Yes. Do I have gas? No, I don't party. However, or, because of the way this is said, if I have money or I have gas, I party. I just don't party expensively. I go to the park and throw frisbees or something. So if I have money or I have gas, I've opened up my possibilities. You can think of this in terms of clothing too. An or, I'm looking for a shirt to wear. I need a short sleeve shirt or a long sleeve shirt. And if you have a closet full of shirts, this means you get a whole bunch of things that are possible. Or maybe I want a blue long sleeve shirt. So I've added more things. I select all of these things, and then I select more things. If I turn this into an and, well, one, this is going to break. We'll just turn this into a blue shirt. Logically speaking, I want a short sleeve shirt. Grab all the short sleeves, but they have to be blue. So now you've narrowed it down to only blue short sleeve shirts. So this is pretty much just a quick little pass at how ORs work, and we'll go through some more examples here in a bit. Hope you're having a great day.